Welcome to class, everyone. We're going to keep trucking along today in Chapter 8, and in Chapter 8 we're going to start looking at something called adverse selection. And in this chapter we're going to look at adverse selection through the lens of Akerlof's market for lemons. One side note / fun fact, Akerlof is an economist who's still alive today. He teaches at Georgetown, and his wife is actually Janet Yellen. So if that name means anything to you, then maybe you'll appreciate this chapter a little bit more. One disclaimer before I start Chapter 8. This chapter, in my opinion, is probably the weirdest chapter in the book because we motivate everything by looking at used cars. And the reason we do that is because when Akerlof was originally building this model, he structured everything around the story of a person trying to buy a used car. And then he demonstrated that that situation lines up quite well with health insurance markets. So I'm going to do the exact same thing. I'm going to show you how the used car market works, and then we'll just translate everything back into health insurance markets. So to get started, last chapter we embraced the fact that there's uncertainty in terms of people's health. And in the model, we did this by saying that every person had a probability of getting sick, P, and the P couldn't equal 0 and it couldn't equal 1, hence there was uncertainty. But something that we assumed last chapter and didn't talk about was we kind of made the assumption that a person knew what their probability of getting sick was, and then the insurance company also knew what the person's probability of getting sick was because they needed that in order to calculate what premium they're going to charge the customer. That's probably a very unrealistic assumption. In the real world, people kind of understand their own health. But in the real world, an insurance company doesn't understand a person's health as well as the person does. So because of this, in the real world, there's asymmetric information. So what this would look like is maybe I know that I have a 20% probability of getting sick, and the insurance company does not know that I have a 25 or 20% probability of getting sick. So the information about my chances of being healthy or sick are known to me, but that information is not known to the insurance company. It's asymmetric in terms of actually holding the information. So in this chapter, we're going to demonstrate that if asymmetric information is a realistic feature of the world, then that's actually going to create a lot of problems, and it's going to cause markets to very quickly unravel, or at least have the tendency to unravel. Okay, so what we're going to do first is we're going to put ourselves in the shoes of George Akerlof. So what Akerlof started thinking about was, okay, in insurance markets, there's asymmetric information. How does that affect the market? Well, to understand this, I'm going to think about another market that's a little bit less complicated than health insurance markets, and that's a used car market. Because in used car markets, there's lots of asymmetric information. So let me just think about modeling everything in terms of a used car market, which is somewhat understandable, and then translate that back over to a health insurance market to see if I can gain any useful information about how asymmetric information would affect a health insurance market. Okay, so let's consider a used car market where there are two used cars being offered for sale. They're the same make, model, year, and on the outside they look exactly the same. So if you're shopping around for a used car, you won't be able to tell the difference between the two used cars that are being offered for sale because they look identical. But what's important to note is that the owners of the used cars, they know a lot of things about the quality of those cars that you don't. They know how frequently they've changed the oil. They know all the subtle details about how well their car performs. And they probably know what the true value of their car is. So maybe the owner of the first car knows that his car is worth $10,000. Maybe the owner of the second car knows that his car is actually a lemon and it's only worth $800. So let's just suppose that both of the owners put a for sale sign on the windshields of their cars. And then let's think about what would happen if the owners of the used cars price their used cars at their true values. So if the guy who owned the well-maintained car put a price tag of $10,000 on his car, and the owner of the Lemon put an $800 price tag on his car. Well, if I'm shopping around for used cars and I see two used cars that look the same, and one is being sold for $800 and one is being sold for $10,000, well, if they look identical to me, and the make and the model and the year and the color and the upholstery and everything on the outside looks exactly the same, then what am I going to do? I'm going to buy the car that's cheaper, because in that case, it seems like I'm getting a deal. Okay, if this were to kind of play out on a large scale, then what would happen is that in the marketplace, only the used cars that are Lemons would be purchased. Because the Lemons, if they were priced at their true value, well, they would be priced at a really low amount. People like bargains, and so the Lemons would be exchanged in the market, and the high quality, well-maintained cars would never be purchased because the price tags would be really high, and consumers wouldn't be able to recognize that they're actually worth the price tag because, again, there's asymmetric information. The consumers don't know the quality of the car, and on the outside they look exactly the same. Okay, let's think about how a person who owns a really well-maintained car would behave. So if I own a used car and I take really good care of it and it's worth $10,000, and my neighbor's got this Lemon that he's selling for $800, and everyone, again, is choosing to buy his $800 car instead of my car that's worth $10,000, then the only thing that I could do to make my car sell would be to lower the price from $10,000 to $800 so that I'm competitive with my neighbor. But if I know that my car is worth $10,000, there's no chance that I'm going to sell it for $800. So what would happen is that I would just say, forget it. Like, I'm just not going to sell my car because I'm not willing to sell it for $800. Okay, as a preview of how this will eventually play out, the consequence of owners who have well-maintained cars removing their cars to the market is going to be that the used car market will entirely unravel because of adverse selection. What is adverse selection? Okay, textbook definition is adverse selection is the oversupply of low-quality goods, products, or contracts that result when there exists asymmetric information. Again, what is asymmetric information? It just means that one side of the market knows more about something than the other side of the market. So in the case of used car markets, the owners of the used cars know more about the quality of their cars than the prospective buyers do. Okay, so that was to demonstrate the intuition of all of this, and it's easiest to kind of see this when I give you an example of a market with two cars, but let's expand this to a market with more than two cars. So suppose you've got gobs and gobs of cars, and each car has a quality level. So let's just suppose we take all the used cars and we line them up from the lowest quality to the highest quality. So the cars that are truly Lemons go towards the front of the line, and the cars that have been owned by grannies who change the oil every Saturday and vacuum them every Tuesday and don't drive them, those really well-maintained cars are going to go on the other end of the line. Okay, suppose there's some uniform market price for used cars. So maybe this is like what Kelley Blue Book says a car of this make, model, year, and everything is worth. So, for example, let's just say we're looking at 2005 Chevy Cavaliers, and Kelley Blue Book says the going price for a 2005 Chevy Cavalier is $2,000. Okay, recall some 2005 Chevy Cavaliers are going to be worth more than $2,000 because grandmas own them, they're super well maintained, and then some 2005 Chevy Cavaliers will be worth less than $2,000 because they're Lemons. And so when we look at this distribution or the lineup of cars, well, not every car is going to be worth $2,000, but that's going to be the market price because Kelley Blue Book says it is. But somewhere in the lineup, there should be a car that's worth $2,000. So let's just find that car, and let's just draw a line there, and label that the price line. And what we're going to see then is that all the cars that are on the right side of that line will be worth more than $2,000. All the cars that are on the left side of that line will be worth less than $2,000. But again, the market price, the uniform market price is going to be $2,000. Okay, so if all the cars in the lineup are priced at the market price, then if you own a car that's worth more than $2,000, you're not going to offer it for sale. You're going to withdraw it from the market because all the exchanges are happening at a price of $2,000, but your car is worth more than $2,000. So if you sell it at the market price, you're going to lose out. So all the cars worth more than the market price are going to not be available on the market anymore. The owners are going to withhold them. On the other hand, if you're someone who owns a Lemon and your car is worth less than $2,000, but $2,000 is the market price for all 2005 Chevy Cavaliers, then you are super happy to sell your Cavalier for $2,000 because you're going to kind of make out in this market. Like, you're going to get a profit because you're going to bring in $2,000, but your car is worth less than that. Okay, so what ends up happening again is that all the cars worth less than $2,000 stay on the market. All the cars that are worth more than $2,000 are withheld from the market. Let's just suppose that consumers are savvy enough to figure out that this is going on. So they're going to be cognizant of the fact that if they go shopping for a used car and the used car market has a Kelley Blue Book price of $2,000 for 2005 Chevy Cavaliers, and so all Cavaliers that were made in 2005 are being sold for $2,000, then they're going to be smart enough to figure out that among the cars that are being sold, those cars that are being offered are going to be worth something between $0 and $2,000. Okay, here's where the asymmetric information becomes sticky. While the buyers of used cars know that among the cars that are being offered, the quality ranges from $0 to $2,000, because of asymmetric information, they can't look at a particular used car and say, I know that this particular used car is worth $1,100. They can't do that because they're the side of the market that doesn't have the information about particular cars' quality. All they're smart enough to do is to figure out if the market price is $2,000, then people who own cars worth more than that aren't going to sell their cars. So if I'm shopping around, all the cars that have a for sale sign on the window are going to be worth somewhere between nothing and $2,000. So if the car buyer were going to just kind of purchase a car blindly, then what he should expect to happen is that worst case scenario, he'd pay $2,000 for a car, he'd bring it home and realize it's worth nothing. Best case scenario, he'd buy one of these cars blindly, he'd pay $2,000 for it, he'd bring it home, and he'd realize, hey, this car is actually worth $2,000. But that would be the best case scenario. Okay, so put yourselves in the shoes of someone who's in that situation. What would you expect to happen if you just kind of blindly purchase a car? Well, you'd expect that on average, you're probably going to get ripped off. Like, on average, you're probably not going to get the car that's worth the $2,000 that you paid for it. So your expectation should be that you're going to lose money if you purchase one of these cars. So in that case, these people who are shopping for cars are just going to throw up their hands and say, forget it. Like, I'm not going to play this game where there's a large probability that I'm going to lose money, and so all the people who are shopping for cars will just quit shopping. Like, they're not going to be willing to purchase a car blindly knowing that they're probably going to get ripped off. And if this happens and suddenly we no longer have a market because no cars are being exchanged because no one's willing to purchase a car. Okay, that's the intuition for Akerlof's market for lemons. What I'm going to do next is I'm going to set up the mathematical model that kind of underpins the intuition. And then next class we'll walk through the math that demonstrates that the result that we got of the market falling apart is what we get mathematically. But today I'm just going to set up the model. first of all, when Akerlof built this model, he tried to simplify the world. So he said, in this model, we're just going to have two parties. We're going to have buyers of used cars, or we're going to have sellers of used cars. He also said that each party would have a utility function with two variables inside of it. Those variables are X and M. So XJ is going to stand for the quality of car J, and M stands for the value of other stuff that the person owns. So both buyers and sellers get utility from cars, and they get utility from other stuff. And if the car is worth more, or if it has a higher quality, then of course you're going to get more utility out of it. Similarly, if your other stuff is worth more, then you're going to get more utility out of it. Okay, the utility functions that belong to the buyers and the sellers are up on your screen. Note that the only thing that distinguishes the buyer and the seller is how much utility they get out of used cars. Okay, recall back to the map analogy. Models, like maps, intentionally try to distill things down so that only the key characteristics of the world that are needed to make a point, or the highways, are included in the model, similarly to how we only put highways on maps. So what that means here is that in the utility functions, the only difference between the buyers and the sellers is the coefficient in front of their X. Okay, pause for a minute and just think about what this means. Suppose each party has stuff, or M, that is worth $100. Okay, now let's just consider two cars. Let's say there's one car that's worth $1,000, there's another car that's worth $2,000. And then let's just shuffle those two used cars between the driveways of buyers and sellers. If those two used cars were sitting on seller's driveway, how much utility would he get out of them? Well, he'd get 3,000 units of utility out of them. So overall, his utility would be $3,100. Okay, suppose, however, those same two cars were sitting on buyer's driveway. How much utility would a buyer get out of those same two cars? Well, he'd get 3/2 times the quality of the first car, or the value of the first car, which is 1,000, plus 3/2 times the value of the second car, which is 2,000. So in total, the utility that he'd extract from those two cars that are worth 1,000, 2,000 would be equivalent to 4,500 units of utility. He still got other stuff, M, that's worth $100. So overall, his utility would be 4,600 units. Okay, again, just let that sink in for a minute. The buyers and the sellers in this example have the same other stuff, so they've both got M worth 100. And we took two identical cars, and we said, okay, sellers, if you own these two cars and you had your other stuff, what would your utility be? It would be 3,100 units. Now buyers, let's just give you those same two cars. What would your utility be? The buyer's utility would be 4,600 units. So this means the same pile of stuff is worth different amounts to these two parties. Specifically, it's how much value they place on used cars that is generating this disparity in their utility levels. So to really just drive home this point, in this exercise, the cars on the driveway aren't different between the buyers and the sellers. It's just the person who's looking at the cars that's changing. So the buyers are going to look at those cars and get more happiness out of those two cars than the sellers. And so that's what makes buyers buyers. They like the cars more than the sellers do, hence they're the ones who are trying to get more cars and buy them. One thing to note, the coefficient 3/2 is somewhat arbitrary. This is the coefficient Akerlof used in his model. All that's important is that it is bigger than the coefficient on seller's X, because we need the model to be set up such that buyers get more utility out of cars than sellers. So if you look back at seller's utility function, implicitly there's a 1 as a coefficient in front of the X. And so here what we see is that 3/2 on the buyer side, their coefficient, is bigger than the 1. So really you could have any coefficient in front of the buyers and sellers' x's. What just needs to be true is that the coefficient on buyers' x needs to be bigger than the coefficient on sellers' x to reflect the fact that buyers get more utility out of cars than sellers do. Okay, again, next class I'm going to walk you through the math that gives us the prediction that I explained, that the market will unravel when there's asymmetric information. But at this point, if you have any questions about the intuition, or if you have any questions about the utility functions, chime in and I'll try to clarify those things. And after that, we'll resume for the exercise. For the exercise today, I'd like you to think about two hypothetical situations and then consider how we would need to update the utility functions that belong to the buyers and sellers of the used cars if these situations actually characterize the world. So question number one is, if sellers had a distaste for used cars, in other words, they got less utility out of each used car than what the car was worth, then what would need to be true about the coefficient on seller's X and their utility function? Question two is, if the coefficient on seller's X and their utility function was 3/2 instead of the 1 that's implicitly sitting in front of the X right now, then what would have to be true about the coefficient on buyer's X and buyer's utility function? Once you have both of these questions answered, then you will be good to go for the rest of the day.